Hi, today I want to talk to you about how communication complexity can give us a new way to understand and improve multi-agent reinforcement learning. To start, multi-agent reinforcement learning studies how multiple agents like robots, drones, or autonomous vehicles coordinate their behavior in a shared environment. Each agent learns its own policy, but the real challenge is coordination. How can we design these agents to share information, cooperate, avoid collisions while still learning efficiently? In a purely reinforcement learning standpoint, this means by designing reward functions that reward each agent when they're successfully able to coordinate and take out a task and punish them when they aren't. The issue with the current model of using these things is that all of this is done in a simulated computer. In these cases, we treat communication between each individual agents as free. This, however, doesn't really make sense in a physical world, since communication is never free in a hardware setting. For example, in a self-driving car world, it doesn't make sense for every car in the world to be able to talk to each other whenever they want and whom whenever they want. The hardware simply does not allow this much of communication. A current solution that many in recent works poses is that by introducing a communication loss term to the objective. For example, this means that you now redesign your reward function that not only rewards agents that are able to carry out tasks, but also able to carry out tasks by reducing their communication. So this also means that you will punish agents that simply talk too much, that even though if they're able to complete the task. This, however, doesn't really solve the issue. Because it fundamentally has an issue because you're just introducing another hyperparameter. There's no principal reason to believe that your chosen cost values will result in a model that reflect the cost of communication in a real world system. Since now you're just basically hypertuning it and redoing it and hoping that it satisfies the hardware limit. Now, this is how communication complexity now enters the picture. Instead of guessing how much communication needs or should, communication complexity tells us the fundamental limit. This means that it gives us the fundamental lower bound of how much communication is needed between these agents in order to solve the given problem. In other words, communication complexity doesn't just add a penalty, it gives us the fundamental limits. And by studying those fundamental limits and finding those fundamental limits, we're able to design multi-agent systems that are more robust, efficient, and deployable in a hardware constrained environment.